My name is Adam Eckerly. I'm a Senior Technical Marketing Architect with the Cloud Platform BU here at VMware.
Hi, my name is Ahmad Yunus. I'm a Senior Technical Marketing Engineer, also in the Cloud Platform Business Unit here at VMware. And in this video, we're going to talk about the vCenter Server and Platform Services Controller 6.5 High Availability. First, we're going to touch on VCHA or High Availability. Then we're going to go into vCenter Server High Availability, then covering PFC High Availability, and then we're going to tie it all together.
Sounds great. So we've kind of started off here with a small environment where we've got a vCenter server with an embedded PSC. We've got a few hosts here, and we've got some VMs on each of those hosts, right? So the big thing when trying to decide whether or not a feature like vCenter HA makes sense is, well, what is the impact of this vCenter server failing, right?
Yeah, so in our environment, if vCenter server goes down, these workloads down here, they're still moving, doing their thing, but now I can't log in, I can't manage, I can't make changes, I can't add, I can't delete,
Things like DRS may not work.
Right.
vSphere HA, that works because that's a host construct, right? But like you said, we cannot manage or make changes to the environment. So for some smaller customers, that may not be a big deal, right?
Right.
Like vCenter's down for a half hour or a couple hours, like you may not even know, because you're not in there all the time doing those things. So something like vCenter HA may not add that much value for you. It may just add complexity.
I think it depends on who all is logging in, as you said, to do it. So in this case where it's maybe just your local IT admin, may not make a difference. But let's say, for example, I also have my business unit logging in to manage their individual VMs. Well, at that point, the last thing you want is that phone call saying, hey, I can't log in, which means vCenter's down. So now you have that added stress of having to make sure that vCenter has that availability so you don't get that phone call.
Yeah, this is a great point. So vCenter HA could make sense for any customer of any size, but you just need to evaluate and look at the requirements. So let's talk about vCenter HA and how it might fix the issue of that vCenter going down and affecting everything that it's managing.
So let's kind of draw out what vCenter HA is going to look like. And I think we should start with the embedded deployment model, since that's what you have over here. So just to kind of review, the embedded is when we have both the PSC and vCenter living on the same box, right?
Yep.
So kind of walk us through what we're going to see when we enable vCenter HA.
Yeah, so when we enable VCHA, the first thing we do is we need to clone the vCenter server. So we'll clone it over, and that node will become the passive node, right? It will have an embedded PSC, technically the same embedded PSC instance on it, and then we'll clone the active vCenter again, and that will become the witness node. This is a standard quorum-based cluster where we need to have that quorum in order for an automated failover to occur. So what Ahmad is drawing right now is the private cluster network. Sometimes can be called the heartbeat network, but it's a network that's just for the replication between the nodes and the communication for things like an election, if there's a failure, so that it's a dedicated network that the nodes can communicate to each other with.
Exactly. So a couple of things we probably should clarify. You said we've cloned this active, so I'm going to put an A here for active, and the passive is an actual clone, right? Now, we've also cloned and got the witness. Are these all the same size?
At first they are after the clone operation, but we can automatically resize that witness node to just a single CPU and a single gig of RAM because, honestly, it's not doing a whole lot. It's certainly not sitting in the data path, and it will never become active or an active instance of vCenter. So we can definitely trim it down.
Okay, that's good to know. Now, let's say active fails, passive takes over, and of course this is a simplified model, so I don't have to worry about load balancer, all that stuff. When that happens, and I go back and I can bring this guy back up, the old active, do we flip back, or do we keep what's happened the way it is, and this guy retains itself as passive.
Yeah, so we don't do automated failback, but failing back is certainly an option. If you just want to know that your vCenter instance is running on the original node, for whatever reason, you can go into the web interface and choose to do a manual failover, and you can fail back the instance to your original node if you choose. But it's completely optional, and we certainly don't do it automatically.
Okay, that's good to know for my OCD when that happens.
Yeah, absolutely.
All right, so now we've covered the simple type of, VCHA. But what about when I have, let's say, an external deployment? How does this work?
Yeah, so great question. So a lot of customers will want to take advantage of enhanced linked mode, right? That is the key reason to use an external PSC. So let's just draw an external PSC out here, right? And then let's draw quickly our vCenter HA cluster. We'll just say this is the passive node. This is the witness node, right? And we've got our private network here.
Okay.
And we've got our active node pointing to the PSC. And the passive node is also pointed to the same PSC. I'll just draw a dotted line to represent that. But it's not active, right? So now we've got, we can absorb or mitigate the risk of a failure within vCenter, right? But what if our PSC fails?
Right. Now we can't authenticate. So again, we can't manage our workloads.
Yeah, so now all this work that we've done here to make vCenter highly available, we've sort of negated that by having a single point of failure up here at the PSC layer.
Okay.
So that's where PFC High Availability comes in.
Okay. So is this a native thing, or is this something else that I have to do to get high availability for PSC?
Yeah, we require our load balancer to provide HA for the PSC layer. So you want to take a look at what that looks like?
Sure. So here I'm going to draw out my PSC, right? And then for availability, I need to have a secondary PSC. Now, let's stop here for a second. Can I do this only within a site, or can this carry on into multiple sites?
Well, you can definitely do it within a site, but if you need to have that kind of availability at other locations, you can just sort of rinse and repeat that same configuration at other locations.
Okay. So now you said I need a load balancer, right?
That's right. Okay. And today we support NSX, F5, and NetScaler. Okay. Any other load balancers we don't officially qualify or support.
Let me ask you this too. With the load balancer, is this actually doing traditional load balancing, or is there something else going on?
No, so we can do sort of a round robin with the PSCs. We do have some sticky sessions involved when we configure the load balancing. So for, by default, a period of 8 hours, a vCenter is going to talk to the same PSC. And then once that 8 hours expires, the load balancer will make a new determination of which PSC the vCenter is going to hook up to. So it's sort of an active configuration with sticky sessions.
Gotcha. Okay, and just to kind of clear this up too, the same replication as we discussed before, licensing, tags, SSO, all that stuff is still happening. The only addition here is the load balancer.
Right.
And the only reason we need it is for high availability. So again, it's one of those things where, if one PSC goes down, the added value of the load balancers, it automatically fails over vCenter or any other solution, let's say SRM, that's using the PSC for authentication to the secondary PSC. And you can sleep at night and not worry about that phone call.
Yeah, that sounds pretty compelling. Even though it does add a bit of complexity, you're getting that automated failover. And if you're using vCenter HA as well, now you've got HA at both layers and you have a more complete solution.
Okay. And I guess at the end of the day, really, it's a matter of trade-offs, right?
Exactly.
Okay. So let's continue down what we have here. So we are going to draw, I guess, The vCenter server?
Yep. And let's make it highly available too.
Okay. So here we're going to draw, and we'll just put the little A here, and we'll draw the P here, right? And here we'll draw the witness, and we'll just have our triangle here, and then we'll point
To the VIP.
to the VIP, right?
Yep.
Now, can I have multiples?
Yeah. So you're not limited to a single vCenter HA cluster in a site. If you have, go back to a scenario where we've got multiple vCenters within this location, not only can you also have them pointed to the VIP, but you can also enable them for HA. And then as far as maximums go, this whole cluster is really treated as one single vCenter instance. Okay. So it applies only one to the maximum number of vCenters within a domain, and it only takes up one vCenter server license.
Wow, okay, so one license, and I can deploy as many as long as the primary is registered in regards to the number of maximums in a domain.
That's right.
Okay,
Absolutely.
that's awesome. I mean, but again, when I look at this, I almost feel like there's added complexity because now I went from something like this where I have even 3 to something like this where I have 2 PSCs, right? 3 boxes for vCenter, so I'm already at 5, including the load balancer. So what happens when I have to, let's say, patch, right? Or,
yeah, it's a lot more machines to manage.
Right, or upgrade. There's a difference there, right, between patching and upgrade. So let's kind of cover what happens when I need to patch this type of deployment.
Yeah, so for patching, if we're looking at the whole thing, right, we want to do our patch our PSCs first. So we can do that. Then we want to go through and we patch our passive and our witness nodes in the VCHA cluster. Okay. Then we fail over, and then we patch the previous active node. Okay. That completes the patching process.
But an upgrade is completely different, right?
An upgrade is different. Basically, again, we'll start with the PSCs, we'll perform our upgrade, and then for a major upgrade for vCenter HA, we'll destroy the cluster. So an easy button click within the UI will automatically go and turn off the passive and the witness nodes. We'll destroy those VMs. Then we can run a normal update or upgrade, to the primary node, and then re-enable vCenter HA after the upgrade is complete.
Gotcha. Okay, so there is a difference between patching and upgrading.
Yep.
Now, a couple things here too is placement. Is there any, can I just place these anywhere if I have multiple data centers? Is there latency requirements? What if I put like my active in data center 1, my passive in data center 2, the witness somewhere, with either one? Is that okay? And what happens, if this active was to fail, and I bring it up over here on the secondary data center, I'm good, right? Like, that all works.
Well, let's take it one step at a time. There's a lot there to digest. So let's start with latency, right?
Sure.
Okay, so I don't want to mess up your diagram down here, so I'm going to kind of go back up here. But between the active and the passive nodes, we require sub 10 milliseconds round trip time. The reason for that is because we're doing synchronous database replication between the active and passive nodes.
And that, when you say round trip, you mean all 3 nodes, just to be clear?
Correct.
Including witness?
Yes.
Okay.
Now, given that, let's assume that you do have 2 sites that are within 10 milliseconds of distance. Maybe in New York City, you've got New York and New Jersey, something like that, sure, that are close to each other.
So a metro type of...
Yes.
Okay.
If you don't have, stretched layer 2, if you don't have stretched storage, then it doesn't really make sense to put your active in one site and your passive in another, and you'd have to have your witness in a third site.
Gotcha.
Reason is because if you can imagine if this vCenter goes down, it's managing these hosts and these VMs.
Right.
It's great if your vCenter fails over to that other location, but if everything is still running over in this data center,
oh, I gotcha.
Not much to manage anymore, right?
Right, yeah. So it defeats the purpose of doing it. And it really sounds like, again, this is vCenter High Availability, not vCenter DR.
Exactly correct.
Okay, now I'm getting it.
There is one situation where it can make sense to stretch the nodes or put them across different sites. Let's go back to that same scenario where you've got New York and New Jersey.
Okay.
And let's say that you do have stretched layer 2 and you do have stretched storage.
Okay.
And you're using something like a stretched clustering where you've got part of your hosts in one data center and the other half of the hosts in another data center. And things are vMotioning around anyway because it's just one big cluster.
Right, they can all talk, yeah, no worries.
Yeah. So in that situation, it doesn't matter where the vCenter nodes live. You can stretch them across because you're not having to worry about changing IP addresses. You don't have to worry about storage and where it's at and all that kind of stuff. So that's kind of the one situation where it can make sense, but I completely agree in principle that vCenter HA is not a DR solution. You want to protect it within a data center if at all possible.
Makes sense. So now that we've covered all that, I think there's one key piece that we need to talk about. When vCenter goes down, how long does it take before, so active goes down, passive picks up? There has to be some sort of time.
Yeah, so we quote a 5-minute RTO for this solution. We definitely want to get to a point where we've got a 0 RTO, but for now, when we have a failure, we'll detect that failure relatively quickly, and then we have to start up all of those services over on the passive node. So if you're doing something like automation or trying to run scripts against using the APIs, the API endpoint comes up relatively quick, like maybe 2.5 minutes.
Because we're running Photon OS now, so reboot times are pretty quick.
Yeah,
it's really the services that we're waiting on.
Yeah, mostly the web client. If you remember, like in the 6.0 days, the web client service could take 10, 15 minutes to start up. Right. Now we've gotten that way down, but it still can take 2.5 to 3 minutes to start up. So that's, if you add those times up, that's where we come up with the 5 minutes.
Sure, makes sense. So in that case, then, should I use vSphere HA, or can vCenter HA and vSphere HA live together, or?
Yeah, great question. So let's kind of look at that. Let's assume that this is our environment, and we've got our active and passive and witness nodes. I'll just say, this is our active node, this is our passive, and this is our witness node. Now, let's say that we have our host fails. We have a PSOD or some other kind of failure that the active node is running on. Now, vCenter is going to fail over to the passive node, right? So this whole failover process is going to complete. Yep. This guy is going to become the active node. This guy is going to become the passive node. Gotcha. Right? But the host it's running on is down. Right. So where vSphere HA comes in is that in this situation, I'm sort of in an unprotected state, right? I only have 2 out of my 3 nodes.
Right, you're degraded.
I don't have a passive node to fail over to if this host fails. Yep. So now vSphere HA can say, oh, well, I'm going to fail over this passive node over to another host, right? So now let's say that this becomes my passive node over here. Now I'm back in a protected state again because vSphere HA has worked together with vCenter HA.
Gotcha. So we can actually utilize them together to protect from host hardware failure and from application failure at the vCenter level.
Right. So we've gone from a failed state in an unprotected state to a failover and an HA failover, and now we're back without having to lift a finger into a completely protected, highly available state.
Sounds great, and I think we've just finished our video.
Sounds good.
All right.
Thanks for watching.
Thanks.